Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be discussing a topic that came up on Big Daddy Linux this past weekend, right after this. So one of the things that we were talking about this past weekend, and I wasn't in the panel, I was just kind of sitting in the peanut gallery, but one of the things that came up was what does it mean for Linux? How does Apple Silicon affect that? And there was a lot of discussion, and a lot of people were giving opinions. Here's mine. I'm going to give you my opinion, but let's talk about first what's going on here. So Apple has been refining their ARM-based Apple Silicon for over a decade now. It began with the A4 on the iPhone 4GS. I mean, that was their silicon. They used other products from other manufacturers prior to that, but the iPhone and the iPads have always been ARM. Today, Apple Silicon is at version A13. Don't know what the next one will be. We'll find out, I guess, this fall. But one of the discussion points they talked about was, once again, performance per watt. But a lot of people have the impression that ARM CPUs are really toys. I mean, we see them on Raspberry Pis, we see them on Odroids, we see them on Banana Pis and Nano Pis, we see them on Nano PCs. We see them on a lot of different things, but here's one for you. The top 500, which is published roughly 6 months at a time, and it just came out June the 1st. The fastest computer right now is the Fujitsu's A64FX, which is an ARM-based CPU called Fugaku, and that is processing at 415 petaflops per second. So if you think these are toys, think again. There is an ARM processor that will definitely outperform your Intel and your AMD today. Anyway, so why is Apple moving away from Intel? Well, one of the reasons they gave was they have shipped over 2 billion products based on Apple Silicon. So they're not ignoring the fact that, hey, I've got this large product base of software that run on my Apple Silicon platforms. They want to take advantage of that. It's only sensible, right? I mean, if you're a marketing company and you're building machines that you want people to use, you want to reduce your effort to generate new ideas and new software products for people to use. The other thing is Intel is stuck on 10 nanometer. They don't seem to be able to budge, and they're still having some issues with the 10 nanometer. Now, we've talked about some of their security issues. That is still ongoing. But ARM has already moved to 7 nanometer. They have 5 nanometer chips, and they are working on 5 nanometer plus, 7 nanometer plus right now. So, yeah, they're already way past 10 nanometers. I know Intel doesn't measure it the same way, but that's their marketing thing. But, it's all about power per watt. It always has been. I mean, I said that on Apple on the when I was in the chat, and a lot of people kind of said they think you're missing it. Well, I don't think so. I don't think you're missing it at all. If you've been around chip manufacturing for any length of time, and I have worked for Burroughs, which did chip manufacturing from custom SoCs all the way up to full-scale CPUs for their A-series line. I worked for IBM, which produced the PowerPC as well as full-scale processors for their 390Z series machines. So power per watt has always been the king in chip design because, if you look at Moore's Law, I mean, that is exactly what we're talking about. The ability to stick more transistors in a smaller and smaller density means that as you reduce the size of the CPU, your performance increases while your amount of energy requirements declines. It's always been the case. So if you listen to the WWDC 2020 keynote, you heard that again. power per watt. That was the reason why they dumped PowerPC long ago for Intel, and it is a factor. It may not be the reason, but it is a factor in going away from Intel. Plus, I think the other thing is that, and they talked about this too, is the common CPU architecture across all of its products. Again, that reduces their cost to develop software, and if you're a developer, that reduces your cost to do testing. Now, there are idiosyncrasies between using an iPhone, an iPad, and a Mac machine. They don't operate the same way. Touchscreen, for example. So how will Apple do this? They're going to introduce this in macOS Big Sur, which is coming this fall. Xcode will support both Intel and ARM development, which, by the way, it already does and has. But in this case, they're generating something called the Universal 2 binary, which will run on both Intel and ARM platforms. So the shared architecture promotes running on other Apple platforms, as well as being able to run. It also works in the converse, where other Apple platform software code can run on the Mac OS ecosystem. There is something called the dynamic translation from Intel to ARM on Rosetta 2. Now, I don't know if there's the reverse. So if you have an Intel-based machine that's older, will you be able to run under Rosetta 2 the newer ARM apps that are coming? Or will the Universal 2 binary automatically take care of that? Don't know yet how well that's going to work. I mean, I remember Rosetta worked pretty well during the PowerPC to Intel transition. In fact, it worked so well that instead of taking 2 years, Apple took 14 months to do the transition, as I recall. Also, there will be support for virtualization and containerization for ARM. I think that's interesting. Now, I don't have all the specifics about the Mac Mini developer kit, so I guess we'll have to wait and find out. So the other thing is the iPhone and iPad apps will run natively on Mac OS based on the Apple Silicon machines. The transition kit is based on I think it's a little bit older processor, the ARM12Z, because they are on the 13 right now, base Mac Mini. And they expect this transition to take over the next 2 years. And as they mentioned, they still have Intel machines in their pipeline that they will be releasing. So, and support for those Intel machines, of course, will be for the next 4 years, as they had said. So I don't know if that's 4 years after the last Intel machine is produced. I would assume that that's exactly what that would mean. But I'm not talking about support here in that context. I'm talking about the ability to run applications on ARM. It's one thing to say it will support the running. It's another thing to say it will work, right? Just because you have plans for it to work, the reality is that some applications may have difficulties because of the way that they're coded. They may be more attuned to the Intel architectures than to the Apple ecosystem. So, yeah, if they're taking advantage directly of Intel features, they may have difficulty in running. My experience on Docker personally is that there's few Docker Hub images that support ARM. There's a few, but there's certainly not as many that support Intel or AMD. So right now, containerization being able to run on the Mac OS, that may be a little bit limited until people catch up and get Docker images that are deployable for ARM, and it will not run Intel code. I don't know if the Rosetta Stone will reverse or not. Don't know. It wouldn't make sense that it would. My experience with virtualization on ARM is limited memory and CPU cores limit the experience. In other words, limit the number of virtualization VMs that I can have. So, yeah, that's a problem. And as you get into these larger and larger ARM, you could buy an 80-core ARM if you've got around $5K to buy one of those CPUs. Yeah, you can definitely do that. But I think they're around $5,800. For an 80-core ARM. A little bit out of my price range. Don't know about you, but a little out of mine. So the question from Big Daddy Linux was, how will this Apple Silicon impact Linux? Well, from a desktop perspective, I don't think there'll be a whole lot of impact, although I think more interest could be generated from the Linux folks on using ARM, because as we start to produce these developer workstations and we start producing machines that run well under ARM, I mean, ARM is less expensive, it takes less power, and it is RISC-based. Now, you could argue that the argument between CISC and RISC has been going on for the last 30 years. I don't want to get there. I don't want to go into that. But, I think that might generate more interest in the Linux community for ARM. From a server perspective, I believe that the Docker images will improve. There'll be more of them that will be able to run on ARM machines, and of course, that will help all of us. Now, will Apple have a huge impact on that? No, but keep in mind that Microsoft is doing the same thing. They're also experimenting. I wouldn't say they're migrating completely off of Intel, but they are definitely experimenting with ARM. So yeah, as those two work more and more together, that is definitely going to improve the server perspective for ARM. The problem that, we'll talk about that. So I believe this will make, the other thing is I believe that the virtualization on ARM will get better, because the ARM chips will roll out with more cores to allow us to do a better job of virtualization, and hopefully the machines will support more memory. Now the Mac Mini developer kit is 16 gig. I don't know what its maximum is. So one of the things that Linus Torvalds talked about was what's holding ARM back and becoming is the lack of development machines using ARM. Some people have said, well, you can just cross-compile, but as Linus said in this same article, this is under real-world perspectives. If you're interested in that, you can look up the topic. It was last year in 2019 that he talked about this. But he said, without a development platform, ARM in the server space is never going to make it. Trying to sell a 64-bit hyperscaling model is idiotic when you don't have enough customers and you don't have workloads, because you never sold the small cheap box that got the whole market started in the first place. Yeah, he's talking about us, the developers. If we don't develop on ARM, then what? Then I have to do some kind of gymnastics in order to cross-compile from Intel on ARM. And I can't run that code unless I have an ARM base to install it on. So that makes it difficult. I can't do any testing until I get it to an ARM platform. If I'm running on ARM, I can test my code directly on ARM. And then I can deploy it on ARM, and I can see how it runs in a integration environment or in a server environment before it's deployed. So yeah, Linus is absolutely right. You want to do your development in the same environment that you develop on. Actually, it's the opposite. You want to develop on the same environment that you're going to run the system on. So that has always been the case. That saves time. That reduces the amount of errors and bugs you find later, because maybe you missed something, or maybe you were trying to emulate. That just doesn't work out well. It gets messy. So does Linux support ARM? Yeah, of course it does. Linux has supported ARM for quite some time now. So it's not, if you want to run ARM, you can. But the problem has always been on Linux. Linux is not as sophisticated. Well, first of all, Linux is not a controlled ecosystem. So like Apple is. Apple can control every aspect of their ecosystem, from the devices they use to the CPUs they use, so they can tightly screw that all down. In Linux, we have choice. We're out here in the Wild West. We can pick and choose whatever platforms we want to run on, whatever devices we want, and assemble the systems the way we want them. And so we have to have support at 3 levels. We need the ARM core, and that would be like version 7, version 8, version 9, and soon to be version 10. So those are some of the things that we need to have support for. The code, the ARM is kind of weird in the way it works, is that if I write code and I compile it for the architecture of V7, the ARM V7 architecture, it won't run on a V8. You got to recompile it for a V8. And that doesn't mean that the code changes necessarily, but the executable, the binary, has to be that. We don't have the sophistication in Linux to produce a universal 2. And I'm not sure that would even be wise to even try to do. I just can't imagine what that would turn out to be. Then you have the system on a chip. You have the actual system support around the ARM core itself to provide devices and support for peripherals and expansion. And then you have the board itself, or the system as a whole. So, yeah, you need support at all three levels for it to work on Linux. I mean, Intel, yeah, it's the same, but it's more wrapped up. I mean, a lot of those things are automatic. I have standards in the Intel world for how boards are produced and how chipsets are produced and how device drivers are produced. In ARM, the ARM doesn't make anything other than the design for the chip. They don't even actually make the chip itself. It's up to each of the vendors that are subscribed to the ARM. So you can get quite a few differences between manufacturers. So, yeah. So, will Apple's move to Apple Silicon affect Linux? I believe it will, but I believe it'll be indirectly. I believe that containerization for ARM will improve, and that specifically being that the Docker images, for example, that are on Docker Hub will contain more ARM images. And I think that will come because of Microsoft and Apple together. Virtualization support for ARM will improve as we start to see chips with larger and larger cores. Now, 80 cores is certainly enough for me on a CPU, especially if you can put 4 of them on a motherboard. But I certainly don't need that. But you may, and a server field may. I know that Amazon is using those advanced CPUs on their platforms for the Amazon their cloud-based systems. I think the third indirect one is I think it's going to produce more interest in the Linux community to use ARM-based machines for both servers, desktops, and development workstations. So I think that's going to drive that. And again, I've said this many times. Anytime that you want success in a platform, whether that be Mac OS, Windows, or whether it's Linux, if you don't have the support at the machine level that I can buy the hardware with it already installed, it's not going to be very successful. I mean, we are a weird breed. Us Linux people are a weird breed. We're willing to take the time to install things and to get things working for the hardware platform that we have chosen. But that's not the case for the real world. They don't spend a lot of time doing that. I mean, if your mom and dad are out buying a machine, you think they're going to sit down and tinker around with it for a while? Well, they might, but doubt it. They probably will call you to tinker around with it for a while. So, but it's always been about performance per watt. There's also the corollaries, the power per watt and thermals per watt. And those are some of the most important things in chip design, and always have been. I mean, if you look at Moore's Law, I mean, that's what it's based on. So ask any gamer, if you don't believe me, what are the 2 things they modify when they're going in to overclock a CPU to get the most performance out of their machines? Voltage, right? And thermals. So, yeah, and that equates to the amount of performance they can gain before it either seizes up, crashes, or starts to throttle back because the temperatures rise too fast, or they just can't produce enough power out of the chipsets surrounding the CPU to be able to sustain that any kind of stability at that particular performance clock rate that they have chosen. But yeah, those are always the things that they mess with. Why aren't people moving from AMD to Intel? I mean, performance per watt, the same thing. Plus Intel is stuck on 10 nanometer. I almost said 14 nanometer because we now have plus. I've lost count. It's probably, I don't know, 6 pluses now on the 14 nanometer, and there are still even the Model 10 chips are still, some of them are still 14 nanometer. So that's what I think today, and I'd like to hear what you think in the comments below as well. I think that I don't think Apple Silicon will have any direct effect on Linux. Apple very rarely would have any effect on Linux. We don't really care what Apple does. Apple will do whatever Apple wants to do, and it is their ecosystem. But their ecosystem doesn't spill over to us. However, I think it will indirectly help us. I think specifically if you want to run ARM on Linux, and again, it's all about choice, right? Containerization, virtualization, I think will improve as the drive to generate chips with additional cores comes about in the ARM space. So yeah. Also, I think we'll start to see. I mean, there have been ARM chips in the server platforms for quite some time. Cavium's been around. Cavium Thunder, Thunder X2, Thunder X3. They've been around for a while. So no surprises there. But those are a little bit big and a little expensive for a desktop. But I think that it might drive those chips into the desktop ranges because Apple has a range of prices that they charge for different various levels of machines. Again, I hope you enjoyed this today. If you did, please like and subscribe. Hope to see you again real soon. And by the way, thank you to the patrons who have supported me. I will put together a list, and we'll be coming around and asking your permission to use your name. And thank you, a big thank you to those that have done that. That helps me. I take that money and I pour it back into the channel. So it helps me produce better videos for you. Hope to see you all again real soon. Bye for now.